Welcome back to the Math of Video Games. We are on episode 4, where we will discuss time. In the last video, we talked about movement. We said that movement is just updating your position over and over again, something like position plus equals velocity. But we also learned towards the end there that there's a problem with this. A faster machine is going to add that velocity more times per second than a slower machine, which means depending on the performance of your machine, your gameplay experience can be different, which is not what we want. So what we need is a way to scale movement based on the passage of time. So instead of saying, move this much every frame, when we can't be sure how many frames there are going to be, what we need to say is, move this much per second. So we introduce a new value, which we call delta time. Delta time represents how much time has passed since the last update. So on a fast machine, delta time is going to be very small, and on a slow machine, delta time is going to be much larger. So let's look at our original movement calculation, position plus equals velocity, and let's adjust it. Now it will be position plus equals velocity times delta time. Let's look at this a little more in depth. Velocity is how fast we want to move per second. Delta time tells us how much of a second has passed. So what does multiplying them actually do? Well, think of it like this. Let's say we want to move 10 units every second. So we write velocity equals 10, and then we say what we've been saying, position plus equals velocity. Well, without scaling by delta time, that's going to move us 10 every frame. So if our frames per second is 30, we'll actually be moving 300 units per second. Not what we were intending. Delta time will take into account the frame rate and either slow down or speed up our velocity per frame. So for example, let's say 1/10 of a second has passed between the last frame and the current one. In that case, velocity times delta time is going to be 10 times 0.1. So instead of moving the full 10, we would move 1 unit. In our example of 30 FPS, that translates to multiplying each frame by about 0.033333 repeating. So each frame, we're multiplying 10 by that amount. That way, after 30 frames have passed total, we've moved a total of 10. I know this can seem a bit dense, but the important thing is this. If you want to consistently move at the speed you've declared, regardless of the speed of the player's machine, you need to multiply your velocity by delta time. The fast machine takes many small steps. The slow one takes fewer, larger steps, but they both end up in the same place. If you've ever played a game at a lower frame rate when you've been used to it at a higher one, or vice versa, you'll know what this looks like because that faster frame rate machine just seems smoother, right? It's because it's breaking down that same movement into a bunch of smaller steps, so you don't notice as much the choppiness of redrawing all those frames. If you're on the slower one, you end up in the same place, but it might seem more stuttery because there are fewer steps in between. Let's try this with numbers. Start at position 0. Let's say your velocity is 10 units per second, like we've been talking about. In our first example, let's have a large time step. Let's say that 1 full second passes between frames. That would be terrible, but let's just roll with it. Then your position is going to equal 0 plus 10 times 1. You end up at 10. It was horribly choppy, you just skipped straight to 10, but you did it. Let's try a second example where we break it down into smaller steps. Let's split that into 2 half seconds. So step 1, your position equals 0 plus 10 times 0.5, which is 5. So you move 5 on that first frame. On the second one, you do the exact same thing, you move another 5. So after 2 steps, you've ended up at 10 again. Now let's break it down into something even smaller. For our third example, let's imagine 10 steps, each of which will take 0.1 seconds, right? That's literally what 1/10 of a second is. Well then each step you're going to add 10 times 0.1, which means you're going to be adding 1. So after 10 steps of that, 10 times, you'll be at 10. So now our movement isn't tied to how often the game updates, it's tied to the passage of time, which should be the same for everybody unless they're in a different universe. And this idea shows up everywhere, it's not just in movement. I mean, yes, you have movement, but you also have animations, you have physics, you have anything that changes over time. In our next video, we're going to build on this. Now that we can move things consistently, how do we actually accurately measure how far apart things are, especially in real time? We've talked about it a little bit before, but not in a way where we can actually make it all that useful. In the next video, we're going to go into more detail about distance.